Good morning, this is Dr. Turner for Fundamental Mathematics A. Today we're going to be talking about fractions, specifically in 2.1 we're looking at addition and subtraction of fractions. What's going to make this easiest is if we have two fractions that have the same denominator. We're going to talk about a couple different techniques, and from there it's up to you which one you want to use. But let's go ahead and get started here. So if we have two fractions that have the same numerator or denominator, it's pretty easy. Let's say we had something like 5/8 plus 2/8. Now, if you think about fractions and pieces as being different things, eighths is that thing. So you have 5/8 and 2/8. So to add these, you just add the numerators, which gives you 7/8. A couple things on this. Remember that your numerator is the number on top, your denominator is the number on the bottom. And if you can simplify, you always want to do that. We'll talk about specifically just simplifying fractions in 2.3. Okay. Continuing on, subtraction is the same. If you have the same denominator, let's say I have 7/5 minus 3/5. I have the same denominator, so just subtract along the top, 7 minus 3. You end up with 4/5. Very basic techniques. If the denominators are the same, you just add or subtract the numerators. Now, where it gets a little tricky is if you have denominators that are different, because just like if I asked you to add apples and oranges, right, you can't tell me you have 17 apples or 17 oranges. They're different things. So with fractions, because they're both values and quantities, we're going to change them to be the same thing. And you can do that one of a couple ways. So start out, let's say I have 8/3 plus 3/5. Okay, so if I want you to do this, there are a couple ways you can do it. I think the most common way is that because you have different denominators, you're looking for the LCM, or least common multiple. If you're using a fancy calculator, it can do that for you, but the least common multiple is the first number that these two have in common. So if you were counting by threes, 3, 6, 9, 12, etc., and then by fives, 5, 10, 15, you're looking for the first number that they have in common, which in this case would be 15. So you want to change the denominator to be 15 on both fractions. So you look over here and say, okay, 3 times what is 15? Well, I'd have to multiply that by 5. And 5, to get 15, I'd have to multiply by 3. Now, if I just change the denominator, it's going to change the value of those numbers. So what we have to do is multiply both the top and bottom by that same value. So on the left, I have to multiply top and bottom by 5. And on the right, I have to multiply top and bottom by 3. Once we do that, we do a little arithmetic. That becomes 40/15 plus 9/15. Once that's done, I can add straight across to get 49/15. So you're changing it so that they have the same denominator, and then it's just like numbers 1 and 2. It's going to be the same process for subtraction. So if I have 7/4 minus 2/3, same thing. These don't have the same denominator, so I'm looking for the least common multiple. That number ends up being 12. So to get to 12, I would do 4 times 3 and 7 times 3. On the right, I'm going to do 3 times 4 and 2 times 4. That then becomes 21/12 minus 8/12. 21 minus 8, that gives me 13/12. Now, a question comes up a lot, especially in like integrated math 1 or math 8, where previously when we were doing middle school math or higher elementary math, sometimes you would be asked to convert this to a mixed number, but typically in a higher level math, we just leave it as an improper fraction. So, yes, 13 is bigger than 12, but we just leave it like that. Okay. That's pretty much it for this section. Now, I mentioned that there's a couple different techniques. So another way that you can add or subtract fractions that have a different denominator is by doing what's known as the butterfly method. So let's say I had 9/4 plus 3/5, for instance. Now, if I'm using the method that I did in 3 and 4, I'm looking for least common multiple. The butterfly method, as it's now known, is kind of doing the same thing. But what you do is you're going to take the cross product. So you're doing 9 times 5, which would be 45, plus 4 times 3, which is 12, over 4 times 5, which is 20. And that's supposed to look like a butterfly. Once you do that, you simplify the numerator and you get 57 over 20. Now, if you look, and again, simplify if you can, and we'll talk about that in a little more detail in 4.3. But if you look carefully down at numbers 3 and 4, that's basically what we did. Here I did 8 times 5. Here I did 3 times 3. And here I did 3 times 5. So you're getting the same thing. It's just a different way to approach it. If you wanted to use LCM or butterfly, you're going to get the same answer. That's it for today, guys. If you have any questions, please attend advisory or ask in class. Otherwise, have a good day, and I will talk to you soon. Bye.